The NPN transistor structure is composed of three regions. It has a heavily doped region of N-type material called the emitter. The emitter is very rich in free electrons. There is a base that is a narrow region composed of lightly doped P-type material. It has a few holes that are mobile and capable of carrying electrons. The collector region of N-type material is not as heavily doped as the emitter, but it also has free electrons. Most of the emitter carriers diffuse through the thin base region because they are attracted by the collector region. Some of the electrons are attracted by the holes in the base region and will move off through the right side, shown here. This is a very small amount compared to the current moving through the base into the collector. In an NPN transistor, the emitter current is the sum of the collector current plus the base current. So, if you have 100 milliamps at the emitter, you will have 99 milliamps at the collector and 1 milliamp at the base. An important characteristic of a transistor is something called beta. Beta is calculated by dividing the collector current, IC, by the base current, IB. So in this example, beta would be equal to 99 milliamps, the current at the collector, divided by 1 milliamp, the current at the base, giving a beta of 99.